Hi guys. So now we're going to take our number sequences and we're going to talk about writing formulas for them. The purpose of the formulas is to find more terms in the sequence. So we got a lot of notation things and some new variables and letters that we have to learn and some notation that's going to be different. So if you're absent today, this is going to be, it's not really going to be a lot of things that you can connect back to. This is really brand new to algebra. You haven't really done this in a previous year. Okay. A and G just refer to the name of the sequence, whether it's an arithmetic or geometric. So when you see the letter A, you know you're talking about an arithmetic sequence, and you're talking about the letter G, it's a geometric sequence. Okay. N refers to the term number, the index. So if I said the fifth term, N would be 5. A sub 1 or G sub 1, okay, the little 1 next to the A and down low is called a subscript. A subscript literally means sub, below, script, writing. So there's writing below the letter. Okay, it's not really underneath it, but it's low and to the right of the letter. It's not like an exponent. It doesn't do anything mathematical. It's more like a name tag. What A sub 1 means is the first term in an arithmetic sequence. What G sub 1 means is the first term in a geometric sequence. So it's the first term of the sequence. A sub N is whatever term you're talking about, the nth term. If N is 5, it's the 5th term. If it's N is 100, it's the 100th term. A sub N minus 1, okay, if I was talking about A sub 5, the 5th term, 5 take away 1 would be A sub 4. Guys, all it means is the previous term, the term before. So A sub N minus 1 means the previous term or the term right before A sub N. D and R, you should know those. It's your common difference for when you're adding and subtracting in an arithmetic sequence each time. And R is your common ratio, what you're multiplying by each time. So I'll scroll that down so you can see it better. Okay, so I'm going to refer to this as our alphabet soup because we got a lot of letters in here that we're playing with. All right. You also need to have out, this sheet right here. Okay, I gave this to you earlier in the week. It's like a study guide that helps you with a lot of the sections of this chapter. And what we're mainly looking, again, it reinforces D is positive when the sequence is increasing, negative. There's a lot of good information on here. But what's new today is this part right here. This is known as a recursive formula. A recursive formula depends on knowing all the terms before. It's basically, you've been doing recursive formula this whole time. Every time I've said, what's the next term in the sequence? You did recursive formula. You just didn't know there was a name for it and a structure for it. But you've been doing it. What this literally means is, let me switch so I can write. Let's make this a little bigger. Okay, what A sub N, okay, we mean, okay, whatever term we're talking about, so whatever term it is, that's equal to the previous term plus your common difference. You've been doing that this whole time. Let me show you what I mean. Let me show you how you've been doing this whole time. Okay. Let's do the first example. All right. if I've got the sequence 2, 5, 8, 11, 14, I'm sure you can already tell me that my D is 3 because I'm adding 3 each time. Okay? So I'm sure you can already tell me that 14 plus 3 is 17. You can already tell me the next number in the sequence. But let's talk about recursive formula, and I'll show you how you've been doing it this whole time. So A sub n would represent the next term in the sequence. It would represent what would go right here. And I would find A sub n by taking A sub n minus 1. Remember, that stands for the previous term, 17, and adding 3. So if I want a term, I have to, that would be equal to the previous term plus 3. This whole bit of writing right here, this whole notation, all that means is the previous term. So 17 plus 3 is 20. So my next term is equal to my previous term plus 3. So you've been doing recursive all along. You just didn't know how to write it, and you didn't know that that was the word for it. Okay, well, let's say I wanted to know what's the I don't want to know the next term. I want to know what's the 100th term in this sequence. Okay, well, I'd have to like sit here for quite a while because I'm only on 1, 2, 3, 4, 5, 6, 7. I'm on the 8th term. I'd have to write out a pretty long list to get to the 100th term. Well, the explicit formula, let me show it to you on your handout. The explicit formula is right here. And the explicit formula tells you everything you need to know to get right to that 100th term or whatever term you want. And all you have to do is sub in the first term and your common difference. Everything else you're copying. Okay? So if I'm writing my explicit formula for this sequence, I need to know my first term. My first term is A sub 1, that's 2. Okay, so I'd start A sub n equals, my first term is 2 plus 3 parenthesis n minus 1. So I subbed in my first term, I subbed in my D, and everything else I just copied, A sub n and n minus 1. Okay, so that formula right there, that formula will tell me any term I want to know. Now I'm not going to do 100th term, let's just do 20th term. 20th term would mean n is equal to 20. So I will just sub in 20 for n. So A sub 20 equals 2 plus 3 parenthesis 20 minus 1. Okay? And you can punch that all into your calculator or whatever. Do not do the 20, take away 1 in your head and write 19 here. Reason being is mainly I want you to do the formula precisely, exactly as it's written. Not doing that part in your head because it helps reinforce the formula, helps you reinforce and remember the structure of it because this is something you have to memorize. Okay, so 2 plus 3 parenthesis 20 minus 1. And I believe this one comes out 59. Okay, let's practice that again. Next sequence. 50, 44, 38, 32, 26. Okay, so what I'm seeing as a D is that we're going down by 6s. My first term is 50. All right, for my recursive formula, if I want to know the next term, I take the previous term. Remember, this whole thing means previous term, 26, and I subtract 6. All I have to do is sub in my d. So it's 20. If I want to know the next term, I take the previous term and I subtract 6. I want to know the next term, I take the previous term and I subtract 6. Again, that helps me get the next term in the sequence, and if I only had to find, a few more terms, that would be one thing. If I have to find, a big number term, I'm going to want the explicit formula. So the explicit formula, remember, is if I want to know a term, I need to know the number I started on. Now this is minus 6. My d is minus 6, so it's minus 6. Okay, parenthesis n minus 1. That would be my explicit formula. I could use that formula to find any term I want. This is saying find the 14th term. So a sub 14 equals 50 minus 6 parenthesis. And again, make yourself write it out. Don't do the 14 minus 1 in your head. It'll reinforce the formula. And that equals negative 28. Okay. Now, there's a couple more in the notes, but I'm not going to do them all. I'll be here forever. All right. This is the same kind of thing, but it's asking for the same thing, but in a different way. Number 1 said the first term is 5, and the common difference is negative 3. And it wants to know the first 5 terms in the sequence, the recursive formula, the explicit formula, and let's find the 25th term. So the first term is 5. Well, that's referring to a sub 1. So I'm going to label that a sub 1. And the common difference is negative 3. I'm going to label that with a D. Okay, so my first 5 terms in the sequence, the first one is 5. They told me that. And then I'm just subtracting 3 every time. So then it would be 5 minus 3 is 2. 2 minus 3 is negative 1. Negative 1 minus 3 would be negative 4. And then minus 3 more would be negative 7. So I did that. Okay. My recursive formula is a sub n equals my next term is my previous term minus 3. One thing to be really careful about is make sure you make your subscripts small and low. Okay, especially those of you who don't have the most precise handwriting. If you write the n's too large, then it's going to look like a times n, and a n minus 1, and that's not what we're saying. Okay, so make sure you make your subscripts small. Alright, so I found the first 5 terms. I've done the recursive formula. Let's do the explicit formula. Okay, that is a sub n equals my first term, 5, minus 3 for my d, parenthesis n minus 1. So there's my explicit formula. Lastly, it wants me to find the 25th term. So a sub 25 equals 5 minus 3 parenthesis 25 minus 1. Remember, this n is not a subscript. We're treating it like a variable. So a sub 25 here would equal, I'm going to pause it and type it in. I hate to say the wrong thing, and I've already done this a couple times today, but I hate. Yep, negative 67. Okay, so that's arithmetic. Let's talk about geometric. Geometric, okay, if you're feeling pretty confident with arithmetic, geometric, there's some changes, but it's not big changes. For example, if we look at our handout, all right, here's our recursive for geometric. We're switching to the letter G instead of the letter A. we have the letter R instead of the letter D, and it's multiply instead of add or subtract. Okay? Otherwise, not a big change for the recursive. So if I was doing this first one, okay, G sub 1 is 3. My R, let's see, I'm multiplying by 2 every time. So my recursive formula, now we're doing G sub n equals, if I want to know a term, I need to know the previous term, G sub n minus 1, and I sub in times 2. That's all there is to writing the recursive for that. So if I want to know the next term, I need to know the previous term and multiply it by 2. So 48 times 2 would be 96. And then if I want to know the next term, I need to know the previous term times 2, 192. And if I want to know the next term, I need to know the previous term and multiply it by 2. Okay, so that's recursive. Explicit formula. The explicit formula has some similarities to the arithmetic, but there's some differences. Okay, so let's scroll down here and look at our explicit. Explicit. We need to sub in a value for G sub 1, our first term. We need to sub in an R, just like we did an A sub 1 and a D. Okay? No big D. We know we need to switch to multiplication instead of add or subtract. That's not a surprise since we're switching to geometric. That's all about multiplication. But here's another big difference. See how our n minus 1 is different now? It's not in parentheses. It's an exponent now. Okay, so that's the big difference about our n minus 1. So if I was going to write an explicit formula for this sequence, it would be G sub n equals my first term, 3, times my 2, my R, and my exponent would be n minus 1. Okay? Well, how do I find the 12th term? Well, that would just mean that n equals 12. So G sub 12 equals 3 times 2, and the power would be 12 minus 1. Again, force yourself to write 12 minus 1. Do not do it in your head. Writing the 12 minus 1 helps you remember the formula, helps reinforce your formula. Okay? And this is the answer to this one is 6,144. Okay, let's do another one that has a fraction in it. Okay, so the next one, whoa, too much. Okay, here's our sequence. Our first value is 64. All right, what's our R? Okay, R, oh gosh, I see we're dividing by 2 each time, but we're not allowed to have an R that says divide by 2. We always have to write it in terms of multiplication. Well, remember that dividing by 2 is the same as multiplying by 1/2. Or you could use 0.5. Okay, so our recursive formula, if I want to know the next term, I need to know the previous term times, and you can write 1/2 or the 0.5. I'll do one of each. Okay, so that's my recursive. So if I want to know the next term, take the previous term, half of it. If I want to know the next term, I take the previous term, half of it. If I want to know the next term, I take the previous term and take half of it. All right, our explicit formula. G sub n, we take our first term, 64, you have to know the first term for that, times, for calculator purposes, it's easier to use the 0.5, Now I will say that if your decimal, if your fraction would be a repeating one, like if it's divide by 3 every time, I would discourage you from using the decimal, because 1/3 is a repeating decimal, and that's a pain to type into the calculator. You have fraction ability on the graphing calculator, use it. Alpha y equals, make your fractions and use them. Okay, so 0.5 to the n minus 1 power. Here again, make that n minus 1 small and look like an exponent. If you make it too big, I'm not going to be convinced that you understand the formula or remember the formula. Maybe you think you're supposed to multiply the n times the 5 and then just randomly subtract 1. Make them small. Okay? 10th term, g sub 10 equals 64 times 0.5 to the 10 minus 1 power. Again, do not do the 10 minus 1 in your head and write a 9. Reinforce the correct structure of the formula. And this one comes out 0.125. Okay? Alright, I'm not sure I got to one like this in class, but this is the same thing as the arithmetic. I'm sure you can figure it out, but I'll include it in the video. Alright, the first term is a, g sub 1, and the common ratio is 5, r. Okay, so the first term is 8, multiply that by 5 is 40, multiply by that by 5 is 200, then 1,000, then 5,000. There's our first 5 numbers in the sequence. So our recursive formula is that any term is equal to the previous term times 5. If I am doing the explicit formula, any term I want is my first number times my r to the n minus 1 power. Again, make that exponent nice and small, nice and high. So g sub 30. Oy vey, I think this is going to be enormous. I haven't done it yet, but it's going to be huge. 8 times 5 to the 30 power minus 1. 30 minus 1 power. Okay, this number is going to be huge. I'm not even sure the calculator will like it. 8 times 5 caret 30 minus 1. Yeah, the calculator's angry. It said that, you know what, this number is too big and I'm going to give it to you in scientific notation. So if you were following along and you're punching things into their calculator, you're going to get 1.490116119, and then it says E21. That means that after the decimal point, there's 21 more place values. Big number. Okay, but you get the gist of what you're supposed to be doing. Okay, so G sub 30 would equal a huge number. No, they're not going to ask you one that large on your Regents. Okay? All right. Have a good weekend, guys. See you next time.